To add these two rational expressions, we first have to find a common denominator. And to do that, we first have to factor the denominators completely. And notice that the first quadratic trinomial here is a prime polynomial because there aren't two numbers whose product is 4 and yet add up to 2. That's just not possible. So let's focus on the other denominator. When I first see x cubed plus 8, I'm reminded of this sum of cubes factorization formula. In fact, in that case, a would be equal to x and b would have to equal 2. So this is x plus 2 times x squared minus 2x plus 2 squared, which is 4. So now that we've factored the denominator of the second one, we see that this x squared minus 2x plus 4 also appears as this unfactorable, this prime polynomial in the first denominator. So the first denominator is only lacking an x plus 2 factor. So if we give it a factor of x plus 2, upstairs and downstairs, now we have the same exact denominator in both of these rational expressions, and we can just then add the numerators together and put it over the common denominator of, let's write it as x plus 2 times x squared minus 2x plus 4. Upstairs we have x minus 2 times x plus 2. Well, x plus 2 times x minus 2 is that famous x squared minus 2 squared, which is then x squared minus 4. And then we have plus 4 minus x squared. So notice we have some things canceling out. We've got an x squared and a negative x squared, so those cancel out. We've got a negative 4 and a plus 4, those cancel out. So finally all we have left is a negative x in the numerator and an x plus 2 times x squared minus 2x plus 4 in the denominator. So there we have combined those two, added those two rational expressions, and reduced it to lowest terms.